Hello, I'm Ken Lee with Seattle Public Utilities, and I'm the project manager for the Ballard Conveyance pipe and pump station construction. Today, I'll be providing an overview of this critical and final piece of the Ship Canal Water Quality project. This project will enhance water quality in our local waterways by improving the management of stormwater and wastewater. In this presentation, we'll cover the Ballard project's objectives, the designs, and how the new conveyance system will help reduce combined sewer overflows, ultimately benefiting the environment and our community. Let's dive into the details. In this PowerPoint, we'll start with the history of Seattle sewer systems, following the development from early inadequate designs to our modern systems. Next, we'll move into the why we are doing the Ship Canal Water Quality Project. This work is crucial for protecting our waterways, for our communities, and wildlife. Then, we'll highlight what has been completed as of the end of 2024. We'll go over key milestones that demonstrate our progress. Finally, we'll outline what work is left to do. At this point, we'll go over remaining challenges and the steps needed to finalize a sustainable and effective sewer system. Seattle began building its sewer systems in the early 1900s. Like many cities at that time, they chose a combined sewer system that collected both sewage and stormwater in the same pipes. These pipes drained directly into local waterways without any treatment, as water treatment technology didn't exist yet. While this system worked when the city was small, it became a major problem as Seattle's population grew. By the 1950s, Lake Washington had become highly polluted because local communities were dumping untreated sewage and stormwater into the lake. Frustrated by the pollution and the lack of regional authority to solve the issues, voters established the Municipality of Metropolitan Seattle, or Metro, in 1958. Metro took charge of cleaning up the water and managing regional wastewater treatment. By mid-1960s, construction of two major treatment plants was completed, the South Treatment Plant in Renton and the West Point Treatment Plant in Seattle. These plants were built to treat sewage from the combined sewer system. In 1994, Metro merged with King County, and King County now manages the region's wastewater. The key message is that we're still using some of the same pipe networks today, which combines sewage and stormwater, and the system doesn't have capacity to handle all of the stormwater and sewage during many rainstorms. This causes combined sewer overflows, or CSOs, which we will discuss more on the next slide. What is a CSO? CSO stands for Combined Sewer Overflow. As I mentioned before, there are areas of the city where stormwater combines with sewage in the same pipes in a combined system. During dry weather or light rain, flow goes to this treatment plant as seen on the graphic on the left. During heavy rains, stormwater fills these pipes, causing the system to overflow into local waters, sending untreated sewage and stormwater into Ship Canal. These overflows can harm fish, wildlife, and the environment, and can contain pollution as seen on the graphic on the right. This graphic shows how the system will operate once the Ship Canal Water Quality Project is in service. Overflows will be directed into the tunnel for storage and then sent to the treatment plant once the storm has passed. This will keep polluted stormwater out of our waterways. The Ship Canal Water Quality Project is a collaboration between King County and Seattle Public Utilities, or SPU. This joint effort aims to reduce the amount of untreated sewage and stormwater that enters local waterways. The project focuses on managing 6 outfalls, 2 managed by King County and 4 by the City of Seattle. Outfalls are the locations where stormwater and sewage overflow can be discharged into bodies of water during heavy rains. By reducing the number of overflows, the project helps protect the health of Seattle's waterways, including the Ship Canal and Puget Sound. This project will keep an average of more than 75 million gallons of sewage and polluted stormwater out of the Ship Canal, Salmon Bay, Lake Union, and Puget Sound each year. It is an investment into Puget Sound's health and our region's future. The project is designed to meet the requirements of a consent decree that SPU entered into with the U.S. Department of Justice, the U.S. Environmental Protection Agency, and the Washington Department of Ecology. The decree mandates that there should be fewer than 1 combined sewer overflow per outfall per year, averaged over a 20-year period. The project's improvements to the sewer and stormwater systems will help ensure that the city meets this goal by significantly reducing the frequency and volume of CSOs, protecting local waterways and public health. So what is conveyance and what are conveyance pipes? Conveyance pipes are used to transport stormwater and sewage into vertical shafts, which then connect to the tunnel. The tunnel moves these flows from Wallingford to Ballard. Once in Ballard, a pump station will push the flows into an existing pipe system that carries them to the West Point treatment plant for treatment. Conveyance refers to the system of pipes and tunnels used to safely transport stormwater and sewage from where it enters the system to where it will be treated. The main storage tunnel is complete. Mudhoney was an 18-foot diameter tunnel boring machine that dug the large tunnel for the project. Starting in Ballard, Mudhoney carved out a 2.7-mile tunnel underground as it made its way to Wallingford. As mentioned previously, this tunnel is designed to hold stormwater and sewage during heavy rains, helping to reduce overflows into local waterways. Mudhoney finished its journey in June 2023, and it was disassembled and removed, with many of its pieces being recycled and sent back to the manufacturer. Mudhoney's journey was a key part of building the system that protected the Ship Canal, Lake Union, and Puget Sound. Here we get into the various project components and what has been completed to date. Work in Ballard focuses on building new pipes to convey wastewater from the Ballard neighborhood to the storage tunnel. An 80-foot tall pump station will be built at the 107-foot deep vertical shaft used for tunneling, which will transport flows from the tunnel to the West Point treatment plant. The completed 24th Avenue Northwest Pier, featuring art inlays by artist Christian French, is publicly accessible and managed by the Seattle Department of Transportation. In East Ballard, work includes the new 55-foot deep vertical shaft constructed near the intersection of 11th Avenue Northwest and Northwest 45th Street, used to transport sewage to a new storage tunnel. The project also includes a below-grade structure that will house essential mechanical, electrical, and odor control equipment. Additionally, a new diversion structure, gate vault, and conveyance pipes connect the existing sewer and stormwater overflow pipes to the storage tunnel. In Fremont, work is underway to finish constructing a 85-foot deep vertical shaft to transport waste into a new storage tunnel. A diversion structure will connect existing overflow pipes to the tunnel, while an 8-foot diameter conveyance tunnel will run under the Ship Canal to carry flows from Queen Anne area. Additionally, an underground facility will house essential equipment for mechanical, electrical, and odor control. In Queen Anne, the work included a new 8-foot diameter tunnel constructed under the Ship Canal to carry stormwater and sewage from the Queen Anne area to a new storage tunnel. Additionally, a 74-foot deep vertical shaft was built to direct flows into this tunnel. New structures and conveyance pipes connect the existing sewer and stormwater overflow pipes to the vertical shaft. In Wallingford, new conveyance pipes installed along Stoneway North and North 35th Street connect existing sewer and stormwater overflow pipes to the storage tunnel. Additionally, a small above-ground electrical building is constructed near the vertical shaft, along with new underground structures for mechanical, electrical, and odor control equipment. The project will also focus on-site and roadway restoration, and public art by artist Ryan Feddersen will enhance the area. Now we've reached the part of the presentation where we will go over the Ballard Pump Station part of the project. Let's take a closer look at what this part of the project entails. This map gives us a clear look at the Ballard project area. If you look at the purple shaded section in the bottom right, that's where the pump station will be located. It is at the Ballard shaft site right at the western end of the tunnel. The exciting part is that the pump station will be built within the shaft that was used to mine the tunnel. Its main job, to pump the combined sewage stored in the tunnel after heavy rain events. The planned Ballard pump station will be an 80-foot tall structure designed to pump stormwater and sewage from the new storage tunnel to the West Point treatment plant. Located at the site of the 107-foot deep vertical shaft, the station will feature both above and below ground mechanical equipment and odor control systems. Our designers were inspired by Ballard's history, the underground infrastructure, and how Ballard looks today. The cylindrical shape mirrors the pump station and below ground equipment space. The frame around the building echoes the industrial feel and scaffolding of Ballard shipyards. The structure will be illuminated at night. There will also be public artwork included in the project. This drawing shows what the future Ballard pump station will look like from the north side. The structure will be built right above the Ballard shaft and will be made of concrete with floors and a roof supported by a metal deck. The outside will have cast-in-place concrete covered with a stainless steel lattice, giving it a modern and strong look. Inside, the tower will hold important mechanical and electrical equipment. In addition, the site will include an urban tree farm, a maintenance yard, and various landscaping improvements. Public art will enhance the space along with pedestrian-friendly features like seating and bike racks, creating a welcoming environment for the community. Let's shift gears to the next part of the presentation, where we'll cover the Ballard Conveyance section of the project. Back to the map of the Ballard Conveyance area to discuss the elements of the conveyance portion of the project. In the project map, the pink line represents the conveyance tunnel alignment. The yellow boxes represent conveyance construction areas, and the purple represents the storage tunnel and pump station area. The green line represents the storage tunnel, and the blue dot represents the pump station. As I mentioned already, pipe conveyance is the transportation of fluids such as stormwater runoff through pipes from one location to another. Conveyance is essential for transporting stormwater and sewage from the Ballard area into the main storage tunnel, helping to reduce overflows and improve water quality. To build this underground system, approximately 2,200 linear feet of piping will be installed, including 1,932 feet of 5-foot diameter fiber-reinforced polymer pipe. A trenchless tunneling method will be used for the installation. This method allows a remote control machine to bore through the ground while the pipe is behind it, minimizing impact to the surface. This approach is ideal for dense urban areas, reducing traffic impacts while ensuring accurate pipe placement. The project also includes maintenance shafts, site improvements, and upgrades to the right-of-way. The Ballard Conveyance portion of the project does involve some potential construction impacts. Traffic disruptions. Construction can lead to road closures, detours, and altered traffic patterns. Noise, dust, and vibrations. Heavy machinery and construction activities may generate noise, dust, and vibrations. Utility disruptions. Existing utilities may need to be relocated or temporarily shut down during construction, impacting services for residents and businesses. Access restrictions. Pedestrian and vehicular access to certain areas might be limited during construction. Water quality management. Efforts are made to manage stormwater runoff and ensure that construction does not negatively impact the water quality of Ship Canal. These impacts will be addressed through planning and community engagement to mitigate disruption and ensure safety during the construction process. First and foremost, we emphasize the importance of communication. We will keep you updated through various channels such as a monthly flyer, notifications, and monthly emails that you can sign up for on our website. To address noise concerns, we're implementing noise mitigation measures to minimize disruption. Additionally, we'll have a safety wall surrounding the site to protect the area and ensure safety for everyone. To help with traffic flow, flaggers will be present when necessary, and we will clearly mark detour routes to guide vehicles and pedestrians safely around the construction area. Lastly, we are committing to monitoring dust and air quality throughout the project. This will help us minimize any environmental impact and ensure a safe atmosphere for everyone in the community. The Ballard Conveyance System and Pump Station are critical components of the Ship Canal Water Quality Project. These systems will work together to transport stormwater and sewage into the storage tunnel and then pump it into the West Point treatment plant, keeping polluted runoff out of local waterways. When completed and operational in 2027, these systems will prevent over 75 million gallons of sewage and polluted stormwater from entering the Ship Canal, Salmon Bay, Lake Union, and Puget Sound every year, dramatically improving water quality and protecting the environment. Thank you for your interest in learning about this important project. If you have any questions now or throughout construction, please feel free to reach out to us.